management, advanced construction management course here.
Yeah.
Last 1.5 month I was here.
Okay.
In the,
But what is the area of interest that you are getting into?
so I want to go to this interiors designing, sir.
Course here.
Interiors. Okay.
Yes, sir.
Okay. Because there is I am told there will be a huge demand for site engineers now by
Yes, sir.
end of February, March. Probably all the free students across Karnataka or across even South India will be hired.
Course here.
Yes, sir.
Yeah, because there are a lot of infrastructure projects coming up in AP, Tamil Nadu, and Telangana,
Yes.
because all these three states are going for election.
Yes, sir. Yes, sir.
So suddenly there is a spurge, and immediately after that you will get Maharashtra and these people. So
Yes, sir.
that would be continuous demand for civil engineers.
Yes, sir. It's a boom, sir, for next future.
Not exactly a boom, but yes, there is a demand, number one, and number two is we also should get adjusted. It is no longer the flash in the pan that used to be a couple of years ago, where you used to get fancy salaries and all these things, because everybody has
Yes, sir.
suffered on their own level, and the way the life has to be led has
Yes, sir.
changed. I mean, in fact, this pandemic in a way
Yes,
has
sir.
hurt people, but also taught us a lot of lessons.
Lot of things. Yes, a lot of
Yes,
lessons.
we have
It,
learned
it
what
taught.
is fundamentally required for us and what is exactly we don't need at all.
Yes, sir. And we learned to live alone. All those things.
No, not only alone. I don't know about how you things became alone for few people. Yes, I am told that many of them were caught because they were not able to get back to their families at their native
Yes, sir. Yes,
places.
sir.
But most
Yeah,
of
yeah, yeah.
us living with the family, we in fact reinvented our families.
Family.
We started learning about each other's matured behavior, especially
Yes,
my
sir.
generation people understood how matured our children have become.
Yes, sir. Yes, sir.
Yeah, I
And
went to
we have spent our time in this pandemic with our families.
yeah.
And
After a long time I started my cooking things
yes,
regularly,
sir.
because that was a passion. Probably
Yes,
that is the reason that even I am good in concrete, because of my timing that I maintain in my cooking. So that
yes,
has
sir.
naturally come into concrete.
Yes.
It's nice to know about it, sir.
Yeah, I cook often, and I also try to twist few dishes.
And sir is expert in so many things. One is quiz master about concrete and crocodile. Today somebody has written to me, sir, is this the same person who is having expertise in crocodiles? And I
Yeah,
asked sir to speak little bit about crocodiles also. Because the
no,
people, when I post something, they start searching in Google.
yeah, that I mean that is the reason my name has become Concroc. Con stands for concrete. CROC comes from crocodile. I am the only civil engineer and to be identified to geotag a crocodile. That is, I can identify a crocodile by its gene, and I can also identify this crocodile belongs to this geographical area, and I can tag it, and I can tag it at the international level. I'm the only civil engineer qualified for that. No one else in the world. And
Wonderful, sir. Sir, can we start the program, sir? In YouTube, around 50 plus people are there and more people are joining.
yeah,
Uh,
I am ready even with
you are
my.
ready, na, sir? Avinash, can you have a welcome address and introduce the sir?
Sure, sir. Okay, sir. Good evening to one and all present here. Welcome to today's session. I am Avinash, BE Civil Engineering graduate from Guru Nanak Dev Engineering College, Bidar, presently a student at CMTI. On behalf of Construction Management Training Institute, Associated Colleges, we welcome all for today's sessions on Infrastructure Lecture Series, session number 6. Construction Management Training Institute is a professional organization for the development of constructional professionals, providing various career-enabled short-term courses on construction management, green buildings, digital constructions like building information modeling, drones in constructions, IoT in construction, etc. CMTI is headquartered in Bangalore. To enable the students industry ready, CMTI are associated with leading colleges for providing practical education during their academics, which includes classroom offline trainings, site visits, and online trainings, providing internships and placements. As we all know, today's session is by Mr. Nagesh Puttaswamy sir, and it's my great honor and pleasure to introduce him. We welcome you, sir, for this program. He is graduated in the year of 1984 to 85 from the University of Mysore. Now he is working as the zonal head white topping and RMD South India for MS Ultratech Cement Limited, and has 13 years of experience in cement and concrete technology. Along with this, he has worked as a consultant heading a sole proprietary firm, Nagesh Consultants, which met the requirements of our various clients pertaining to structural designs of buildings. And additionally, he had rendered structural consultancy for various projects with several architects in Bangalore. He has about 33 years of experience in the field of civil engineering, and he was consultant for the companies like Karuturi Networks Floriculture Division and MRF Tires, etc. When coming to professional achievements, he was in charge of a training and mentoring of professional personnel for white topping pilot project at Kharagpur, West Bengal, along with the IIT Kharagpur. In charge of the QA, QC, and technology transfer management of the white topping work happening in Bangalore city and other parts of Karnataka, and was in charge of the construction of quality assurance of the concrete white topping of bitumen road technology demonstration project in Bangalore, Mysore, Karnataka, Chennai, Tamil Nadu, Hyderabad in Telangana. It is impossible to mention all his accomplishments as there are a lot more. His achievements have been recognized by awards, and one of those, he was a structural consultant for St. Mary's Church, Navanagar, Bagalkot, which was awarded ICI Karnataka Hubli Dharwad Center Ultratech Outstanding Concrete Structure Institutional Building Section for the year of 2007 to 2008. It is indeed privilege to have you with us today, sir. Thank you so much, sir, for coming and bestowing us with your presence. Please join me in welcoming Mr. Nagesh Puttaswamy, sir. Hope this session will help you all to gain knowledge, and I request everyone to mute their mic. If you have any doubts, please leave the message in chat box, and even YouTube people also comment, and they leave the message in a comment box, and we heartily welcome you, sir. Over to you, sir. Thank you.
Thank you, Avinash, for wonderful introduction about the program and about the expert.
Thank you, sir.
So over to Nagesh sir, and I want to introduce Mr. Sivaraman Rajendran, the expert of CMTI, who is also joined with us. Sivaram sir is attending this program from Saudi Arabia, and he is delivering a lot of lectures in CMTI also. I join with Mr. Sivaram Rajendran on welcoming you, sir. Over to you, sir.
Uh, Hello, Mr. Sivaraman. Nice to meet you. I think I had heard you
again, sir.
Yeah, I had heard your voice in my previous presentation with CMTI when I talked
Yes.
about white topping. And my dear students, faculty members, and professionals, let us start. In fact, I have been working since about 3 a.m. this morning. Somehow, yesterday, when I went through my presentation, I always felt, because this is normally, this presentation is a 4 to 4.5 hours training session. Whatever I have taught here is a training session that I take up for people executing a rigid pavement project. It could be white topping, it could be concrete road, or anything where the entire team of contractors to the consultants to department engineers supervising this. And in that case, I always felt what I spoke in the previous session was always a little bit tough and difficult to handle. And maybe because of the type of audience that were there and all these things. But after my presentation last Saturday, lot of my friends and colleagues from Ultratech also called me back. They said, "Sir, you were in a different dimension talking about this rigid payment today. I don't know, because you were much more simpler than all these things, blah, blah, blah." They went on telling. And I said, this is a serial. It is not a single episode, or it is not a program. It is going to be a serial, because I had episode 1 last Saturday, and this would be an episode 2, something like a TV serial. So let us start the presentation. Quickly, a recap. In the last presentation, I spoke to you about why rigid payments, or alias cement concrete payments, are a necessity to be understood and to start implementing now, because of the depleting oil resources and all these things. And I also went on to tell you some basic difference between how to handle and advantages of concrete payment, and also went on to tell, because concrete pavement is a different type of construction and a different kind of mechanism working on field, there needs to be a slight fine tuning and carefulness to be adopted by documentation process and all these things we saw. And now, since yesterday evening, when I completed my first rehearsal of the thing, I went on seeing that the more I try to explain, the more is left over. So I will quickly take you through. Anybody, any organization, any college who would like to have a detailed presentation on a specific thing. If you say that, "Sir, we wanted to know definitely on concrete mix design, or we wanted to know on pavers, all these things," you can contact Ashok Kumar, CMTI. Through them only, we will arrange a 1 hour lecture for each of these items, where we can take it out in detail. Now, I will try to put up things. Number one, I will not go in detail what code already tells you. It is there, black and white. But when you are implementing those points in field, there are several things that ignorantly, intentionally, or accidentally, or the relative position at site, we may have to correct ourselves, or we may pace our work in a different way than what the codal restrictions say, or we might face some peculiar situation or peculiar challenges. What all I have seen in each of these things, I will go on telling you. And a very important thing, I will take a little bit of time on telling you about the various equipments that are used, because concrete roads or rigid pavements are a new thing to majority of us. It's a new thing, because things have started moving so widely, vastly, very recently. So let us start the presentation. Well, today we will be talking about construction aspects. Majority of them construction aspect. Yes, uh, most of the guidelines are available in terms of code of practices. When it comes to pavements or roads in India, we are struck between two codes. I mean, two organization, the Bureau of Indian Standards, which define IS code books, and the Indian Road Congress, which defines specifications and various design aspects of for roads. So, and each of these things will counter refer themselves to the other code in some specific issues. Now, here I would like to tell you, uh, not many of us know, because IRC codes are not easily available, so easily available in the public domain, because you have to buy them mostly in physical form. No e-editions are available, but you will have to buy them in physical form of the book. But many colleges, many people who are in transportation are having these access to these things. Basically, there are four codes that would come into picture: IRC 43, and all of these codes were revised in 2014 to 2018. Many of these codes were revised. Number one, the practice, construction practice for tools, plants, and equipment required for construction and maintenance of concrete road, that is cement concrete road, is IRC 43. After 1972, this code was revised in 2015. And correspondingly, code of practice for construction of plain concrete pavements, IRC 15, and construction of guidelines for concrete mix design for payments. Little bit tricky here. I will tell you in the corresponding time what is tricky about this. IRC 44, and it's an elaborate code. You have to go through it before you make a mix design for PQC, or payment quality concrete. And I have seen many of our colleagues and many of our fellow professionals blindly or ignorantly following 0.7 root FCK is equal to FCR, and design that, solve this equation and design the concrete for the FCK required, so that FCR is minimum of 4.5 MPa. Yes, when you are designing for a pavement quality concrete, there are some fine tuning that you can do, especially to get that flexural strength in concrete, which is hidden in IRC 44, that you will have to take up. And I will tell you, if I have to talk in detail about this concrete mix design, I will have to frequently cross refer between 10262 and IRC 44, and many of the IS codes that have been recently revised, including those of aggregates. Then guidelines for conventional and thin white topping, it is also there. It is one of the ways of the rigid payments. This is the list that you will have to look out for. And very important is some of the fringe areas, like guidelines for design and construction of fiber reinforced concrete pavement. Very essential, because modern day many cities are going in for thin concrete overlay over their existing bituminous road, because they are all fed up repairing their old roads again and again. So you have to look out for that. And then even in the highway segment and other state highways or district major roads, making as regular soil based, macadam based sub base is very expensive. Water is scarce. Because of all these things, use of dry lane concrete and stabilization of soil has come in. So you will have to know all these things. And then let us say, I would always mm, go like conventional design. When you design a building, you will not design, you will always design from the topmost floor to the bottommost floor. However, the construction starts from foundation to the topmost floor. Similarly, even in the basic construction of concrete road, or any pavement, whether it is bitumen or concrete, The levels for the road starts from the top of the drain, because water that is drained off from the surface of the road should get into the storm water drain. Otherwise it will be suicidal for the roads. It will be suicidal for the road. And believe it or not, unfortunately, ignorantly, or by oversight, continuously most of our municipal corporation roads are suffering because of that. Because the top of the drain, which is normally constructed few months after the road is made, assuming that the road will increase its depth when relaying of bitumen happens, the top of the drain is kept above the surface of the road. Now where does the water go? So the water starts stagnating in the road. Water refuses to go inside the storm water drain and continue the natural path. They start flowing in the roads and urban flooding. One of the reasons behind urban flooding is that. And very important, the bitumen road is allergic to water. They fail very quickly. So handling of shoulders and allied works, you should understand first. You might be constructing that as a later part of the construction, but you should understand and you should fix the levels of that first, based on which you are going to fix the top level. Number one, very important, is shoulders. And especially in case of concrete road, it very vital, because concrete is a very rigid material. At the end of the edge of the concrete pavement, you have a sharp edge. Suppose your shoulder is not strong enough, due to rain the shoulder gets worn out. A vehicle, especially a two-wheeler, going to the edge of the road has got all possibility to skid off, roll down, or topple. So anything can happen. So what is a shoulder? Serves as a lateral support. This is the fundamental objective. The shoulders on either side of the road, whether it is bitumen or cement concrete, should give a lateral support to the entire structure of the pavement. Until and unless that is done, the pavement's durability deteriorates, because the edge starts failing. Then it also provides protecting highway interference, like water seeping into the different layers, or water moving in between the layers of the pavement, and all these things. And then it also should serve as a safety track in case of narrow roads, when a vehicle is overtaking the other vehicle, or when a vehicle gives way to the another vehicle, they have a tendency to slip off from the main pavement way and come into the shoulder. Now, please note, if the shoulder is not strong enough, gradually the shoulder will wear away and the edge of the pavement get exposed. So this is very, very important. And in case of highways, every now and then the shoulders have to be extended beyond a normal limit, so that or some tourist important places, you will have to provide an additional shoulder width, where people can stop their vehicle, have a look at the scenic beauty and all these things. Then um, these are the things that it is there. This is how a shoulder looks like. You can see here, up here is you can see that, well, I would take my this one. You can see here, this is the edge of the pavement, and this is the edge of the base layer or the DLC layer. This is again on the other side of the thing, you have the similar thing going on. So that is where your support is required. And this portion of the what you call the pavement is very vital. How strong, how durable, how weatherproof you have done it. So they have to integrate themselves. And normally This is how it is. A 7,000 mm or a 7-meter carriageway is expected to have a 2.5-meter shoulder on either ways, either side, and for various practical reasons, you cannot. Now, when it comes to the rigid pavement, concrete is a very hard material, unlike bitumen. So, and right from the beginning stages of its or early stages of its life, it needs a higher stake or the thing. So what we will do in case of concrete roads, after the concrete road is laid, in order to prevent erosion, we have two key habits to do. And the first one is like here up, you can see here, sorry, I have multiple pointing devices. So you can see here, this portion is where the shoulder begins. So this shoulder, and there would be a geotextile to prevent erosion. This shoulder is tied up with the construction of the PQC, and there will be a drainage layer to ensure that the shoulders never become soft and fail. So that is how it is. Or in most of the urban centers and highways passing through very important curves and these things, even in curves of some hilly areas, we do use curbstones. The curbstones of various shapes are used to protect the edge of the pavement. Beyond the curbstone comes the soil or the secondary shoulder. So that is how we manage. And in many cases, there is a precast drain, especially in urban and habitat areas, human habitat areas. You will have a drain, normally an RC drain or a stone masonry drain, which would also behave as a threshold for the concrete PQC. And in urban centers these days, because of the various reasons, like we would have situated our service lines, etc., in the sides of the concrete road or the rigid pavement, we go in for interlocking blocks like this, which would ensure that these blocks can be removed, the necessary servicing could be done, and we can take it ahead. So the shoulders are to be handled very carefully and delicately. The pavement is normal. We have the similar kind of thing. But when it comes to shoulder, you have got two sensitive areas. One, highways and regular roads, that is outside the human habitat, place to place in between human habited areas. You have shoulders which have got a different mechanism. You cannot spend too much on the shoulders, but you should have a stable shoulder. So how do we do it? And the other one is habitats, urban and hilly areas. These are the two conditions that we have to look out for. In case of the in case of many of these cases, what has happened is people would go to this. In many cases in modern day, I have seen the PQC is laid like this, tapers down, and soil is filled here. They call this shoulder. Now what happens? This is a tapering thickness. T is reducing here, because of which the load coming here is W, load coming here is also W. Now stress is increased, it fails here. And what we actually require is this, something which supports here. This is a tricky thing to achieve outside in the areas. So okay, I lost contact of my, okay, fine. So this is the way you can see that shaded area is the shoulder. Now, typically there are some important fundamental things that you can. When the carriageway is straight, the shoulders can be of equal width on both sides. But when the there is a curve in the road or the carriageway, the inner lane shoulder should be wider than the outer lane. Why? Most of the vehicles have a tendency to come to the inside when they are taking a curve. You can see many of our friends riding things in the out in the city also. When they are taking a right turn, they have a tendency to come to the left lane of the other perpendicular road, and you suddenly, when you are traveling towards the same junction, you will find suddenly a vehicle coming on your lane, and that is how it is. So the inner lane should be slightly wider than this thing. So typically when the shoulders are not just made, they have to be maintained also. In some many cases, you can see here, what you see here is a repairing of the shoulder going on. Like this is a concrete pavement. We are pouring dry lane concrete, that is roller compacted concrete. uh, this concrete is poured here, and road rollers are run over this, so that the compaction achieved will give us high strength with low cement, and also easily breakable concrete in case it is required. And what you see up here is the curbstone based shoulder. Now this shoulder is the end of the road, and then you have this drain. Both of this will support the thing. Now this here, the payment is not done, only the DLC is laid. Payment will be done here. This is the top level of the payment, and once the payment is laid, this will be the chamber, and the water runs down here into the drain. And in case of highways, you can see here, this especially in the hilly areas. This is one site in somewhere in Udupi district. You can see here we are rolling the side lanes or the shoulders for better thing. And this is the other view of it. DLC has been laid. We are rolling here, and concrete of a varied application, like DLC, sometimes M15 concrete, sometimes M20 concrete, sometimes stabilized soil is used. This shoulder is equally important in bituminous road also. There we use a bitumen concrete with a slightly different thing, and that would be the edge retainer also. In majority of the cases, even there nowadays, people have started using DLC or stabilized soil to this, so that the percolation and other things is prevented. But in case of roads in embankment, this problem is double, because in most of the central lane where the central pathway comes, we would have rolled it to the best possible extent, and whereas to the edge there is a slope, so your shoulders need to be equally strong. And these days many of us are avoiding this inclined stabilization of the soil. Instead, we have a vertical RC or a geotextile tensioned panels to hold the earth in vertical phase. And one modification that I have seen in few European countries, and I have heard about this, is this one. See, this is actually a roller compacted, this is PQC. And what they are doing here is, it's a cell-filled concrete. That is, there is a plastic or what you call fibrous small cells that is stretched like expanded sheet metal, into which dry lean concrete is filled. Thereby it is held together, and rollers are run over it. Normally, don't imagine a steel wheel roller to go here. When we say roller compacted concrete for the shoulders, it will be always pneumatic rollers that go in. That is the rollers with rubber or regular tires. So this is another way. But this one, I am told, lot of studies have been made. This is one of the stablest shoulders that you can think of. And in case of highways in where we have an island and other things. This is how we make it. This is one of the highways that recently I visited, and this is again another highway that is being done. And when it comes to urban centers, things change. Here you have intersections, you have uh, inclined intersection. That is how we handle. Normally what we do is, when there is an intersection, we keep the shoulder like this, because the vehicle that comes here has a tendency to go near and near. You cannot have a right angle joint for the shoulder. You will have to have a curved joint, so that the vehicle, because please note, when you are driving a four wheeler, you will understand this. When you are taking a turn to the left two wheels will have a higher dragging force on the earth than the right two wheels. This is called dragging effect, or what you call traction load on the. Similarly, when the inclination comes, these are the things. Let me quickly take you what are the things that you have to look out for. Number one, then, very important that you have to look out for is, in urban centers there are bus stops where you have to allow the bus to go inside and pick up people. That is how we make an arrangement of the shoulder. We will extend the shoulder till the edge of the bus shelter. Then comes handling of drains and service ducts. Drains, there are many of them. Okay. Number one, along the road, that is transfers. Along the road, you have to have drainage. So this is typically a crude way of doing it, and this is a Malnad way, where stones are available, the slope is available, pitching is already done. You have a pitching done here, you have the soil and a little bit of pitching done here, and the natural water flow is maintained. Thereby, water that falls in goes here, and this is not a rigid payment. I told you these are typically the same detail for both, but I have taken an example where you can see the example of how it is done. In case of very flat roads somewhere, or for example, when you have got a road that is cut into a hill, on the one side of the road, you will have to put water towards the hill, and the other side will be towards the slope of the hill. Now, if you put water towards the hill, you are going to create instability. So you have to have a drainage layer like this. You have to have a geofabric to ensure that the things are kept in place, and we will have to have a perforated pipe which takes the water away longitudinally, and occasionally in a cross duct, the water is taken to the sloping side. These are precast drains that are being done. This is an urban road. What you see in the bottom is an urban road where top gratings are used. This is typically how a cross drain looks like. These are very, very vital in all types of roads everywhere, including inside the city. This is another way where typical textured, architecturally beautiful slabs are made. But when it is very, very highly slopy, or a malnad or a mountainous area, things become a little bit difficult. And because this is not very affordable, we are having a frequent landslides in Indian roads. We are having these frequent landslides in Indian roads because of this. Probably in a similar kind of conditions in Alps in Europe, there are not as many landslides are as this, but there might be an avalanche, but not landslides as many as. What you have to do is, you have to have step by step cross drain. So when water comes down here, you have to build a drain here, and this would also act as stability of slope. Then step by step, and then there would be a sump tank or a drainage point which takes the water down to the valley. So the end would be a toe drain which goes along the slope of the road, to ensure that there is, at a particular point, it crosses the road and goes into the slope, and then goes into the valley. This is engineeringly, theoretically the right way, but because of various constraints, especially like funds availability, we are not able to do this, and we have the problem of stability of slopes. Then in case of urban centers, this would be very important. Like you have service ducts. Normally in cities, um, typical IRC recommendation is every 200 meters you should have a cross duct. That is cross ducts. Please don't confuse between duct and drainage. Duct is only a passage across the road. Drain is something that you have fluids flowing through it. Okay. A duct can cater for a drain also. Duct can cater for other services also. So every 200 meters you need a cross duct, and the location of these ducts are again critical. Many of us forget this. In a straight stretch 200 is okay, but when the road curves itself, whether it is even if it is shorter, you would have to have a cross duct at the beginning of the curve and the end of the curve. And along the bus bay, you cannot have the cross duct in the bus bay, so you will have to have the duct just after or just before the bus bay. And in case of cross junctions, it is always dangerous to have cross ducts in the junction, so it will be slightly behind, like what I have shown in the dotted line there. Typically the other service ducts are like this. Number one, it is a multi-purpose duct. Here I can take water, I can take sewer, I can take cables, I can take electric cables, or anything can come from anywhere. So what happens? We will have multiple of this. For water, we will have a duct inside which we will place our pipes for sewer and water supply and gas. So this will be an isolated thing, and the other one will be to run cables, and within the cables there should be an insulation for charged cables and uncharged cables. And especially with the era of optical fibers, you will have to have careful. And these things are nowadays available. There are many people who are manufacturing precast placed with these circular holes in it. All you have to do is place them inside your drain so that the pipes don't entangle themselves, the ducts don't entangle themselves, they are passed through these holes and taken up. So that is how it looks like. You can see here on the one side, on the this one is the where the fluids go, and this is where the cables go. They are side by side. On top of it we have one single RCC slab going on, and this normally is used as pedestrian crossing. Two in one. This is how it looks like right there in the pedestrian crossing. Below the pedestrian crossing, you have the service duct like this. They are all short panels that are kept one side by side. So if something goes wrong, something has to be serviced, they just remove these plates, go inside, change the cable or repair the cable or repair the pipeline, and they just close it back. No digging of soil, no breakage of services, nothing. And when you are using shoulders, please, especially in case of paver blocks, unfortunately many contractors and many engineers of old school of thought are not very much aware about the way the paver blocks behave. Old school of thought, maybe people who are senior to me or people who are not exposed to these new advances in these technologies, they blindly use this. They think that assembling all these things like a jigsaw puzzle gives us the payment. But the durability of a what you call as paver block, interlocking paver block, and the strength of the interlocking paver blocks lies in the lateral constraint. You should have periodic lateral constraint either in form of RCC plates or stone plates coming at regular intervals, thereby isolating these blocks into small panels of a known dimension, because this might vary between the size and shape of the paver blocks, also the substrata. So these are things that you have to do, and this is one typical case where the contractor had forgotten And the very first rain, we saw bulging of these paver blocks, and I had to visit the site because of these frequent problems. Then when I found out that, I had to ask them to replace it. Unfortunately, the department had specified the spacers to be provided, but the contractor had forgotten, the supervising engineer had forgotten about it, and they had to redo the whole thing. This is how it looks like, and this is how we had to do that. And when it comes to machinery and plants, you please note IRC 43 2015 governs almost everything that I am going to talk about now. Almost everything that I'm going to talk about now. Not only the plant, the way that they have to be used, why they are used, everything is available. I will show you only some of the critical parts of it. Number one, earth moving and sub-base construction. This is a typical thing that we all have learned. Nowadays, what is happening is they are not just allowing the subgrade like what it is up here. What they would put is they'll try to stabilize this soil also, thereby they get a better, stronger foundation. There will be a sub course which will be granular, and then there will be a base course. Normally in case of PQC it will be a DLC, and then concrete pavement. In case of concrete pavement where permeability has to be close, there will be a plastic layer in between. This is how the construction of sub-base goes on, and this is very tricky in case of black cotton soil. We will have to have a very perfect what you call as drainage layer. Please note, whenever there is a black cotton soil, when you are providing a GSP, the lesser the fine aggregate, better will be the performance, because you will have the drainage of water from the surface, and ensure that you allow the water that is drained to get out. If you close all the sites and allow the drainage layer also there, the drainage layer itself becomes poison for the road. And in this is how things go on. We roll and final just before. And this one is a small layout that adopted concrete roads in their layout. That is how things went on. And typically hilly area, highway, and highway here. And this is how, this is another option of doing uh, urban shoulders. They use what is called as pervious concrete, where concrete does not have fine aggregate. It allow the water to go in. Please remember, you cannot blindly replace ordinary shoulder with pervious concrete. Pervious concrete is a system, it is not a material. Once there is pervious concrete, you should allow the water to go down, and the water that goes in should be given a direction to flow, and there should be a storage, and it has to go further. These are the equipments that normally used. Number one is the steel roller that you all know. What you see here is a pneumatic tire roller, and what you see here is a vibro roller. That is, you have a metal roller and also a pneumatic tire, both of them put together. And this is very unique. Not many of you would have seen, especially the students would not have seen. We used to call it ship foot roller. They are called with different technical names also, different brands also. They literally punch soil so that it is like a ramming your concrete cube or ramming your soil, pressing it. So when the roller goes on, it gives load in a very small area, thereby the consolidation or the compaction is better. And when it comes to batching plants, very critical. Please note, the site mixing drum mixer will not make PQC. Drum mixers, ordinary drum mixers will not make PQC. It is not capable of making PQC. Any concrete above M25 needs a way batching mixer. If you are still adopting it, there are ways to it. You can contact me a little bit later. I will talk to you about how to manage all these things. But when you should have a way batching system, and then only you can get economical concrete. So number one, what are the things that you have to have? Number one, you have got the code of practice for tools and plants. Then you have got guidelines for mix design for pavements. Apart from that, because IS codes are revised much later, 2018, 19, and 16. You have to look out for mix proportion 1026 to probably look at the finer aspect, both of these things. Then only you can get an optimized mix. Then you will have to look out, very important. Even the recent IRC code that is there in 2017 has frequently referred to and frequently reminded the users to refer to IS 383 for aggregates, which is 2016 edition. And nowadays, people cannot wait for 28 days strength to come out. So there is a standard practice to know the strength of concrete in an accelerated way. That is, we cure the concrete at higher temperature using boiling water or heated water at a constant temperature. We keep the water at a higher temperature. All other thing is constant except the temperature of the water in which the cubes and beams are immersed, and then we take it out at 24 hours, 48 hours as per the requirement. There is a code even in IRC, there is a code even in IS code book for accelerated testing of concrete. You will have to follow that. And as far as concrete batching plant is concerned, most of you know this one, bottom left. You know this is a regular batching plant, that is an RMC plant. But what you have for this one is these two.
हा ते डब्यावर घालतात, डब्या एक महिन्याचं पुरे एक बॉक्स दिले त्याने 30 गोळ्या. हा ते बॉक्सचं नाव घाल मला पुरा क्लिअर.
Hello. Okay.
I think someone's mic was unmuted. Amit.
Yeah.
Muted, sir.
Okay. There are some automated mini batching plants which are portable. Now your work goes on in a highway for kilometers. You take the batching plant slightly ahead of it and start batching the concrete, supply it in a very short distance. Go ahead. These are mobile batching plants that are there. Most of them are equipped with way batching system. And what you see on the right hand side is another way batching plant. I mean, that can be you can semi-manual, that is, people will load aggregates into this bucket here, and this will be dumped into the drum, and the drum will drop the concrete here. And these are mini batching plants which are mobile. They themselves load it, they themselves transport it. As the transportation is going on, the concrete is mixed, the water tank is there, everything is way batched. And some of the advanced versions of these machines do have a provision for dispersing admixtures. And in India, right now, as far as my knowledge goes, this is a very popular brand, Ajax. They have several models, including admixture in dispensing possibilities. In fact, in many cases, I am using this, and even in rural roads, I am recommending people to hire this rather than spend too much on cement for manual mixing correction. So then comes Paver. Paver is like the old English proverb, horses for courses, which for what you are riding the horse, you have to know, otherwise the horse is likely to tumble. So the pavers have to be selected, number one, based on the size of the work. Why? I cannot recommend a very high-end paver because every Tom, Dick, and Harry cannot own these pavers. So somebody is owning it, they will allow it on rent. So when I'm having a very small project, I do not have any financial option to go and get the best of the machines. So I will have to compromise on this. But if the same project is very vital, I will have to go and get it, and I have to make the corresponding financial implication available for my tender. And then, where is the work located? Is the work in narrow roads? Then no point in getting a large paver. And if the importance of the work, then I have to look at what kind of paver. What can I use? Combination of pavers. And then intensity of traffic on the road. Higher load, higher pavers, all these things will be there. And then, very important, in many cases, the space available for the pavers to move governs which paver will come inside. I have faced this situation, and in those cases, suddenly the road width became very small because of a small temple coming in between or a big banyan tree coming in. So I have to stop paving at a particular point, rotate the paver by 90 degrees, take it to the other side of the temple or the tree, start paving once again. The balance patchwork in between I had to do in alternate method. So how did the pavers evaluate? This is my personal experience also, because I have been involved in concrete roads since 2009. Not many pavers were available in India. Sorry. This is a typical thing that we used to have. We used to have two C channels holding the concrete as formwork, and we had this heavy I section or a channel section with a small vibrator mounted on it, so that there is a vibration inducted. When the regular vibrators, like here what you can see, this one used to compact the concrete, but this one was used to finish the concrete. Now what we found here was they used to have small ripples because of single thing. And you can see me working here, and I said, thanks to most of this, I'm not a transportation engineer background, so I learned these things on field, being a material science man. This is me working there. One of the contractor and his fabricator came out with this novel idea. Sir, one channel is giving ripples. Let me introduce another channel which will also give ripples. The first ripple will be neutralized by the second ripple. Indeed, it worked. Indeed, it worked. And what he did was, instead of putting one heavily vibrating petrol or kerosene driven vibrator, he switched over to electrical vibrator, which had a little bit lower vibration intensity pitch, but intensity was higher. So the finishing became better and the driving became easier. You can see that I am pulling that paver with a fractured arm. You can see here my hands are fractured. Still, I was able to pull it out. That is how it is there. And this method became very popular in case of rigid pavements. Most of the concrete roads that are there in Mangalore city, this is from Mangalore city. And Mangalore city, we have to be very proud that for a given city, the highest percentage of concrete road in a city, not don't go by the length, highest percentage is in India is Mangalore city. So most of these roads were done like this. And when it comes to rural area, these kind of things may not work. And that one is a very slow process where manually we had to pull. We wanted something that is mechanically moved. This is a truss paver. There is a typical lattice girder here, triangular lattice girder, and below this are two rollers, three rollers, depending upon the option. This engine rotates and vibrates everything, but you have to have a series of 40 vibrators. This will run this entire machine on a set of rails that is nothing but the formwork for concrete road. You can see here, that is how it works. The driver can sit over here. You can see here, this is the driver. You can see that the machine is running. This is the channel. It is doing a dual job of being the rail for this, as well as to hold the concrete. That is how it is done. Then comes more scientifically designed and better pavers, that is 3-roller pavers. That is, there are 3 rollers, one to level the concrete, 2 to compact and finish, and third one rotates at a slightly higher speed with a small gap, thereby ensuring there is a vacuum and draws out the surface water. This is how it looks like. This has got an automatic or what you call as microprocessor control. It can adjust the camber as per your requirement. It can move even in curves. It can increase or decrease the speed. It can dip the rod, control the vibration. It can lift back the vibrator needle so that it continues. Then comes, the other pavers. You can see here, The other kind of pavers that are there, these are slip form pavers where no formwork is required. Please note the concrete here is 0 to 10 mm slump, and the concrete is not carried in a transit mixer, but it is carried in a tipper or dumper. The concrete is dumped into the site. I will show you those details, but what you see here is a small pad here. These pads will rub over the surface so that the surface bleed water that has come out is taken away, and thereby at any given section of the concrete, no water cement ratio is variable. And prerequisites, especially in case of slip form paver, you will have to have a series of pegs like this, over which there is a wire that is going on, which will tell the paver, or which will indicate to the paver what direction to move, how it has to move. And this is how these are different types of slip form paver. Suppose I have paved this 2 days ago. My paver is working. My concrete comes on this side of the road. How do I transport concrete to here? This is an arm of the extended arm of the paver. Concrete is dumped onto this belt, conveyor belt, that goes into the conveyed into the paving area. Thereby, the concreting happens. These are different types of modern day, since a lot of works is going on in India today. We have lot of things going on. These things have come in recently, and many of the Chinese model have come very cheap. They are totally electrically driven. No diesel required, one generator is required, totally electrically driven, much smoother. Of course, question mark, Chinese durability. I have seen many of them failing very often, but many people who bring these people, these pavers, they always bring 1 or 2 motors extra, thereby they can put it. Even the vibrators are driven by electrical motors. This can take up, and the levels are available. These are multiple rollers where you can choose the roller that goes into your paver. You can see here the series of rollers, different weight, different finishing. This is a blank truss, and that is how things are there. And to finish the concrete, you need number one, the channels for holding the concrete in case of slip, in case of fixed form paver, where you need a former, and slip form paver is you don't need a former. In case of fixed form pavers, the concrete accepted is between 40 mm slump to 65 mm slump, above which the paver will result in very bad, below which also paver will not work. The very critical, and water cement ratio for concrete in PQC is very low. So attaining strength in concrete for PQC is very easy, but attaining the right kind of workability, maintaining the right kind of workability at the construction point is a perfect challenge for an young engineer. There are a lot of innovations that can be made. So typically this is how you do the fixed form. You lay the form work and then go about it. And this what you see here is a bull float. It is nothing but a trowel of a mason. It tries to finish the surface after the roller has gone in. And then how do you align it? You can see here, this is a fixed form paver. We have to align it in the right way. We have to mark it. You can see here we have marked, and then there will be a series of pegs that are driven. These pegs will continuity, all these things will tell the which direction the paver goes. But you can see the small cross link here. This is the level of the top. This gives the reference for the top level of the concrete. And these are sensors in the pavers, modern day pavers. There will be a horizontal sensor and there will be a vertical paver sensor. The vertical sensor will always tell the paver to which direction go, and the horizontal sensor like this will tell what is the top level of the concrete. Accordingly, paver starts making its own adjustment. At the beginning of the work, I will just tell the paver 180 mm, 340 mm, 250 mm, what is the thickness, and I will set the 0 for the cable at that point, and the paver goes on and on. You can see here, that is how you will have to work out on small things that see, in earlier days when we were not very I told you, this is an infant technology adaptation these days in India, but even though it is hundreds of years, 100 years, more than 100 years old, in earlier days we knew that channel has to be there, and we used all types of lousy things to support these. Later on we understood just a small bracket like this on the channel will do the job. And continuous evaluation is going on. In all probability, this girl is also logged in today. She is a PhD scholar. Her name is Dhriti. And this is Professor Swati from IIT Kharagpur, both of them. They are making a study of rigid pavement in dynamic condition. As and when vehicle moves on that, what is happening inside? In Indian, most of the Americans and European countries had this data, but in Indian condition, we did not have this data much. So this study is being made by IIT Kharagpur, and that is how I am involved in that work at West Bengal, Kharagpur. And that is what you see here. This is how the concrete is dumped. I will tell you. I'll show you. See here, up there, and I will show you. This is zero slump concrete. It refuses to come out of the dumper also. In many cases, thud. In many cases, we will have to bring a JCB to move that. And this is then again leveled. It's a messy job. Most of these concrete road works happen in night because of the temperature. You need to have a JCB which will spread the concrete to a certain level. After that, you can see a series of vibrators here, and there is a leveling tool. It will feed the concrete. And all these modern day paver machines have an ancillary unit which will finish the concrete and also texture the concrete, also spray curing compound. This is texturing, this is curing compound sprayer. This is how texturing is done. And the temperature of the concrete is very, very vital. It should not be more than 35, 36 degrees centigrade, because the differential temperature you will have to look out for. If like this winter season, outside temperature is already 28, 22 degrees, 23 degrees, then I have to put my concrete much near to it. I cannot have my concrete at 30 degrees. So 420 kgs of cement in most of the PQC. So then I will have to use ice shavings or chilled water to make my concrete. That is how it looks like, the finished surface. What you saw there up here is a mobile concrete lab by Ultratech. We have the basic concrete testing facilities in those labs. In the finishing work, you can see here, I think this is a video. I showed you the bull float. This is nothing but nothing other than the mason troweling the concrete. It's a huge trowel. This is how the finishing goes on. You can see here the close-up, and somewhere when the joining and other things happen, we do have to have these things where dowel bars are kept and at frequent intervals. But in many cases, this is a tailor-made or a enacted finishing one. This is the modern day bull float. And in case of rural roads where this kind of equipment is not available, in regular feature, I may not recommend this, but in case of very remote places where you are building rural roads, please have this one. This would ensure that the surface bleed water is taken away from the surface, thereby excess of water that could dilute the strength of the surface of this concrete is taken away. So this would be an ideal thing. After the bull float is done, this is how it looks like. Some of the pictures I have taken in the city life so that it is easier for light and other things. This is texturing going on. These are all finishing. And very important is after the texturing is done, just when the concrete is about to retain its shape by itself, it is still wet, we have to spray a curing compound. It cannot wait for, because one dimension is infinite. One dimension is infinite. That means the area, surface area is infinite. The area available for evaporation of water is infinite. So you have to use curing compound. That is how you have a lot of things, right from a small agricultural sprayer to anything like a machine. And then comes cutting at a designed uh, panel size. You have to cut the concrete. And in case of regular concrete pavements, they will be designed around 4.5 meters, where there will be a series of double bars. That is where you cut and allow the concrete to crack, and that will always ensure that the concrete will shrink and expand, if at all, during in the dowel bars provided. Whereas in case of unreinforced continuous paving, we will have to cut it at a regular interval. In case of white topping, we will cut it at 1 meter by 1 meter. So this is how the cutting looks like. This is the cutting machine, blade, and then some of these things were innovated by our own people. This is what I saw in Bangalore, where water is very, very scarce. Now, instead of bringing a tractor, wasting water, because if you spray water from a tractor, 10 to 15% is I mean, maximum 10 to 15% is absorbed by the gunny bags there and the concrete. The other 85 to 90% will run off into the soil. Is it worthwhile? No. This is something that the contractors themselves innovated. What they had was a temporary pipeline being laid, and at frequent intervals, they bought in these water tanks. But the tractors used to come and fill up this. There used to be a small pump, which is portable, electrical pump. They used to keep it here, pump water along a particular distance. This agricultural sprinkler like this worked, and they used to have a generator which goes up and down the site. They used to have the sprinkler about 40 to 50 feet, that is about 10 to 15 meters, sometimes even 40 meters, depending upon the strength of that pump. The water was very optimally used. That means almost 10% of the water was used to wet this, and the wetting was more efficient. That is how it is. Handling of associated works, you have to look out for the direction in which the dowel bars are to be placed, the general depth at which the dowel bars are to be placed. This is practically impossible to manually place it. So what we normally do is, using reinforcement steel, we make a chair like this. We place the sleeves of the dowel bars at the right place, inside which one side is closed, the other side is, we apply lubrication, like uh, chassis, I mean, solid grease or similar material, and we insert the dowel bars onto it. And this is how things can be done. You can see here, at the required distance, we have placed the dowel bars. That is how things can be there. And the other thing, you will have to look out for the site testing. In case of fixed form pavers, 25 or 30 to 65 slump. In case of slip form pavers, 0 to 10 slump. And in case of pavement work, it is the flexural strength which is very important. 4.5 MPa on the dry day traffic is allowed on that road. Flexural strength. So beams are to be casted along with cubes. So that is a typical lab setup. When it comes to most challenging thing that has recently happened is Yamuna Expressway. I have heard many engineers who have worked in this project making presentations at various places, different people talking to about it. And in the early days of Yamuna Express Highway's inauguration, there used to be a talk that many urban and villagers, especially the youngsters from these villages, used to go and ride on this vehicle, this road at a very high speed. And they were demanding the cop who penalized them for high speed driving to write it on their challan what speed he was caught. And that used to be a boost for that youngsters to go back and boast about what speed he achieved his bike or car. But one important thing I would like all of you to observe here is the shoulder. This is a concrete pavement, but the edges are bituminous here. They have still made provision for some of the utilities, if at all they come, to be taken up. That is a very excellent design. This is how it is. You can look out for that. And uh, the when it comes to rigid pavement, I'll quickly take you through this white topping. This is also this thing. I will not take details, but there are some specific works that are unique for this. For people who do not know what is white topping is rehabilitating a worn out bituminous surface by layer of concrete, but this layer of concrete will give more strength to this, but utilizes the residual strength of the existing road, thereby making it better. In that case, one operation that comes to it is removing the surface of the bitumen that is rutted. This is called milling machines. These are the nozzles. These are the diamond headed studs which will mill the surface. Most of these white topping works are right now happening in case of urban centric things. But people from Bangalore or people who travel to Bangalore often, I would request you to go on nice road for a drive between Mysore Road Junction to probably almost the Kanakpura Road Junction. You would drive on this white topped road. This is whenever milling machines are not available, we do use indigenous methods. And very important thing is this: what you see here is not fire, it is compressed air going out to clean the surface of the grit. And recent example, I told you Yamuna Express Highway, that is very, very important. And the strength of this was also checked by this. A MiG was landed on Yamuna Express Highway before it was commissioned. That is the strength at which we can build concrete roads on. And that is how it was checked on. You can see it is just landing and taking off. These are the statistics. These are available on the internet or the public domain now. And there are continuous studies being made. This is how I told you that Ms. Dhriti and Dr. Swati are doing this study. This is way that we have laid out several sensors. These are the different sensors that we have taken: vibration, temperature, strain gauge, everything has been put here. And this is how things have been placed. You can see here the sensors are there. You can see here, that is how the things are going on. Now the results are coming in. Due to pandemic, I have not been able to go to Kharagpur. Otherwise, I would have projected some of the details how this is performing. And as recently as 14th December, there are some amendments to IRC. Number one, waste plastic in case of wearing code has been IRC approved, SP98. Second one, cement treated granular layer. If you do not want to have very huge this thing, WBC, you can always go for cement based treatment, what you call as cement stabilized. And you can also use a lot of fly ash and GGBS in it, so that the stabilization is much more with natural materials and better. Geosynthetics are permitted, and very important, soil stabilization is a part of IRC now. And jute and other fibrous material, natural fibers, are also recommended based on various conditions. You can see that they are recommended. This is what you have to understand. There would be a lot of things coming up, and I would request you, don't just look at one code, especially when you are looking at construction code. Always read the plant and machinery code and the construction code together. But when you become a materials man, look at IRC for concrete mix design along with IS 10262, IS 383, all put together. And please note, blended cements are permitted in IRC now, which is far better to control temperatures. Use of secondary cementitious material is also recommended, is also permitted according to IRC. So thereby you can further control the temperature. And you can also use materials like microsilica. Now, not only reduce the cement content, but whatever you save by reducing the cement content, you can add a little bit of microsilica, also get high early strength. You can play around with all these things and take about this. Thank you all of you for joining us for this presentation. Namaskar. And I would like to say that anybody who is listening to here, both academicians as well as professionals who have joined for this program, you have any doubts on construction of regarding the PQC or regarding the construction of rigid pavements in any part of India, Ultratech has got a dedicated department for rigid pavements. Of course, we call that white topping division, but we are dedicated for construction of cement concrete base roads. And also, of course, we also look after special applications of concrete in construction. We have people who have got experience of building roads across India. We will always be ready to chip in. And for the academic professors and teachers here, look at concrete for as PQC, especially concrete for higherly strength. Thereby you can allow the traffic at an earlier date than 28 days, probably 15 days, probably 10 days. Like that, every week saved will be appreciated by the public. So these are the areas that you can do research on. I am open for question. Back to Ashok.
Thank you, sir. Thanks for your wonderful information. I hope the layman who is watching your last session and this session can do the PQC. That much details you have given about the machinery, about the mix, about the procedure, and about the opportunities, about the cost. It's a wonderful session, and a given time, within given time of 2 sessions you have told, on that you have covered the entire life cycle of that particular rigid pavement. I request my colleagues, Mr. Prabhakaran is there, he is PQC man for L&T, he is available, and Mr. Rajendran is available. You can share your words a little bit for the audience about the this particular sessions you attended, and share your knowledge also. Please, next 5 minutes is for you. Request Sivaraman sir.
First of all, thank you, Mr. Nagesh, for another enlightening session given to us. We thoroughly enjoyed this session. And anything and everything which has interaction with the soil and foundation is tough to understand. But somehow you have made it very easy and light by means of real life photographs and actual case studies. You made it a little interesting and easy to understand. I have done some piles with instrumented piles, I can say.
Excuse me, sir. Nagesh sir, can you unshare the screen so that we can see our Mr. Rajendran?
Yeah, I'm just trying to unshare it.
Yeah,
somehow.
so we can see the audience also. 1 second, sir. Sivaraman sir, 1 second. Yeah, now you can speak.
I have done instrumented piles sometime way beyond before 10 years ago, where we fixed the load cell at bottom of the pile cage and analyze throughout the life of the structure. We monitor the behavior of the pile, whether it gets corroded, how it behaves under the load, what happens 30 meters below and all. And similarly, the same technology was introduced